each training round. So this is the upper limb functional movement training. And I designed this experiment to examine effects of RAS incorporated in functional movement training on reducing the severity of movement abnormalities, including slow movements and also irregular muscle contraction in POE. And I hypothesized that RAS incorporated in training reduce severity of slow movements and also irregular muscle contraction in POE. I recruited 17 POE and also 18 healthy controls. And then I used a 16-item prodromal questionnaire and also 15-item community assessment of psychic experiences to detect POE from the community. And this was the randomized control trial. I randomly allocate POE to either the experimental group receiving the functional upper limb movement training with the aid of RAS, or either to the control group receiving the same functional movement training without the aid of RAS. And then this diagram shows the procedure of the movement training. So before experiments, I asked each participant to use their dominant hand to pick up a bean from the left target ball and then move the bean to the main target ball. And then they pick up another bean from the middle target ball and then move the bean to the main ball. And then do the same thing for the right target ball and then back to the left target ball. So they need to repeat this movement until the end of the time. And I asked each participant to do it as quickly as possible so I could detect their baseline tempo. And then for the experimental groups, I will prepare RAS with the required tempo. And then I play the RAS when the experimental group executed this upper limb movement training. So they need to try their best. Every time when they hear a beat, they need to pick up a beat. So it's like beat, 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 beat. So I also use metronome to prepare the RAS. So it's the same as what you have already heard before. Okay, and then this is the 21-day training protocol. So for the first week, from day 1 to day 7, for every day 40 minutes training, so the participants need to execute this hand task for 3 minutes per round for a total of 3 rounds. When they listen to RAS with a normal tempo, which equal to 100% of baseline tempo. And then they have 5 minutes break. And then they did the same upper limb movement task again when they listen to RAS with a quick tempo, which equal to 105% of the baseline tempo. And then they have 5 minutes break again. And at the end of one day's session, they execute the hand movements again for 3 rounds when they listen to RAS with a fast tempo, which equal to 110% of the baseline tempo. So this is the 1-day training protocol. So for the experimental group, they need to hear the RAS I prepared, and then they need to try their best to follow each beat when they pick up a beat. And then in the second week, the training content actually is the same, but I added additional 5% to each RAS tempo. So the normal tempo become 105% compared with 100% in the first week. And then the quick tempo become 110% and the fast tempo become 115%. And in the third week, I add extra 5% again. So the normal tempo become 110% of the baseline tempo, and then the quick tempo become 115%, and then the fast tempo become 120%. So this is the 21-day protocol for the experimental group. For the control group, the time frame, the movement tasks were exactly the same. The only difference is that the control group participants did not receive any RS. So for example, on the day 1, so the participant in the control group need to execute this hand test as quickly as possible without listening any RS until 3 minutes per round. And then for a total of 3 rounds. And then they have 5 minutes break and then do the hand test as quickly as possible again. And then they have 5 minutes break and then the same for the last round. So they repeat the same protocol for the 21 consecutive days. So in this result table, the first column indicated the information of demographic data and also the kinematic data. We found that there were significant group differences in NMT and also NNMU. So we could observe that PLE had slow movements and also irregular muscle contraction. So this result, is consistent with the earlier findings that both movement abnormalities coexisted in PLE. So this is the main result table. In the first column, I indicate the information of post-test NMT and also post-test NNMU. I conducted one-way ANCOVA to control for the possible confounding influences of the pre-test movement scores and also other demographic differences at the pre-test. And in this analysis, the independent factor was the group, and then the dependent factors were the post-test NMT and also post-test NNMU. We found that there were significant group differences at post-test NMT and also post-test NNMU. Experimental group showed less severe movement abnormalities, which means that RAS incorporated in training reduced the severity of movement abnormalities in PLE. So RAS incorporated in training was effective to improve the movement performances in PLE. Then furthermore, after this research, actually, I also feel interested in knowing that now what if I change RAS from metronome beat to classical music rhythm? Because music is very common in our life, and it's also a very interesting type of RAS. So if I change the mode of RAS from metronome beats to classical music rhythm, I would like to know whether RAS was also effective in reducing the severity of movement abnormalities in PLE. So I conducted another research, and I recruited 15 PLE and also 15 healthy controls, and I also used a 16-item prodromal questionnaire and also 15-item community assessment of psychic experiences to detect PLE from the community. And similarly, this was the randomized control trial. I randomly allocate PLE to either the experimental group receiving the functional movement training with the aid of rhythmic classical music rhythm, and or either to the control group receiving the same functional training without the aid of classical music rhythm. And then this diagram also shows the procedure of the movement. So again, each participants were asked to execute a movement test as quickly as possible before experiment, so I could detect their baseline tempo. And then for the experimental group, I prepare RAS here, which is classical music rhythm. And then when the experimental group conduct their movement training, I play this classical music rhythm. So they need to try their best to follow each beat of the classical music when they pick up the beat. And then for the control group, the same, they did not receive any stimulation of the classical music rhythm. They just basically execute a hand test as quickly as possible. Oh, and then so I play the classical music rhythm here to let you hear how this RS sounds like. Okay, and then the protocol is the same as what I used before. So for the experimental group, they try their best to synchronize their movements with the classical music rhythm. For control group, they just execute their hand test as quickly as possible for the 21 consecutive days. So this is the result table. In the first column, I indicated the information of NMT and also NNMU for the right hand and also left hand. In this result, because I would like to obtain more information, so I measure the movement abnormalities not only at the right hand, but also at the left hand. Even though, under our training protocol, actually only dominant hand of participants was trained. But I assessed the movement abnormalities at both hands. And I conducted one-way ANCOVA again to control for the confounding influences of pre-test movement scores and also the demographic differences. Okay, and then the results show that there were significant group differences at NMT and also NMU adipose test for right hands and also left hands. And when we observe this data, we found that experimental group had less severe movement abnormalities at the post-test after we control for the possible confounding influences of the pre-test scores, which means that RS here, classical music rhythm was also effective when they incorporated in the movement training to reduce the severity of movement abnormalities in PLE. So for these two studies I have already shared, the result, again, could be explained by the common neural mechanism I have already introduced before. People with PLE have aberrant basal ganglia, which may affect their signal integration within their brain. When we provide RAS may activate the neural activity in their auditory cortex, and through multiple neural connections, like the direct neural circuits in the cortical level, to pass the information of RAS to the motor cortex, and then to further improve the upper limb movements, including the movement speed and also the movement quality in PLE. So these studies offer the initial evidence that the non-pharmacological program we developed here was effective for tackling the movement problems, which are initial signs and also risk factors of psychotic onset. And then, these two studies also offer evidence that this early intervention program was effective for people in the initial stage of the psychosis continuum. So the healthcare practitioners may consider to use the RS in their training protocol for people in the early stage of the psychosis continuum. Okay, and then for the future research, our team plans to conduct large scales randomized control trial, because as you can see, although we have really found a significant result of RAS effect, but our sample size are quite small. So we plan to conduct large scale research in the near future to further validate the effectiveness of RAS incorporating training. And then we plan to collect neuroimaging data in auditory cortex and also motor cortex to examine the brain responses to the brain changes in response to RAS. And then we also plan to assess the long-term functional outcomes, like the hand function of doing daily activities, and also the long-term clinical outcomes. For example, we target our research participants after they receive our intervention for a year, and then we assess their severity of psychotic symptoms to see the long-term effects of our training programs on the psychotic symptoms. Okay, and then now I move to the third aspect, because my team also replicating the investigation to the PD patients. So now I also share our current research findings about the effects of RAS on movements in people with PD. So Parkinson's disease, which is abbreviated as PD, involves neurodegeneration of substantia nigra of the basal ganglia, which leads to decreased dopamine secretion, and thus further causes hypokinetic movements such as bradykinesia. And then this is also the reason why my team is replicating our investigation to the PD patients, because you could see that their movement symptoms somehow a little bit similar, and then their brain dysfunction is also somehow similar, although they are not the same diseases. Healthcare costs for PD is increasing annually because of the gradual reduction in the pharmacotherapeutic effects on movements. Therefore, we need to develop new and also effective interventions to allow clinical practitioners to choose to tackle the bradykinesia problems in PD patients. And even though for the PD patients, they also have the dysfunctional basal ganglia, but RAS also show high potential. Literature has already indicated that RAS is effective in modulating the gait speed in PD patients, but the same it remains unclear whether upper limb movements in PD patients were able to respond to RAS as well. So my team conducted this research to examine the immediate effects of RAS on the upper limb movement speed in PD patients. And then we hypothesized that upper limb movements become faster when PD patients listen to RAS with a faster tempo. So the study adopted 3x3x2 mixed design with one within factor, which was RAS, including 3 levels. And then also one within factor, which was task, including the left-hand task, the right-hand task, and also both-hand task. And also one between factor, which was participants, including 23 PD patients and also 23 healthy controls. So my team also used Purdue Pepboard test to assess the upper limb movement speed. So similarly, before experiments, we ask our participants to use their, for example, right hand to insert a pin into the hole as quickly as possible within 30 seconds without listening any RAS. So we collect their data of baseline tempo and then do the same thing for the both hand task and also the left hand task. Okay, and then in the experiments, we prepare RAS with the required tempo and ask PD patients to try their best to follow each beat of RAS when they insert a pin into the hole. So I played it again, but it's the same. You know, it's a metronome. I use metronome to prepare the RAS with the required tempo. Okay, so this is the result table. The first column indicated the information for PD patients and also healthy controls under the left hand, right hand, and also both hand condition. And then the second column indicated the information of different RAS condition. The study conducted 3-way ANOVA to examine the interaction effect and also the main effects. No triple interaction was found, but we found RAS by task interaction. So the study conducted further analysis to examine RAS effect for each population, for each group, under each task condition. And then we found that the group differences were significant. So we could see the data here. PD patients compared with healthy control. PD patients had slow movements for the left hand, right hand, and also both hands under each RAS condition. And in addition, RAS effects were also significant for PD patients and also healthy controls under each task. So we could look at here. Faster RAS induce faster upper limb movement speed in PD patients for the left hand, right hand, and also both hands. So the study supported that upper limb movements in PD patients also responded to RAS. And then this result also show high potential that we may further incorporate RAS into the functional movement training and to examine whether our movement training could improve the movements in PD patients. So this result, again, if we would like to try to use some neural mechanisms to explain why RAS is effective, then, you know, RAS could activate the motor cortex, okay, and then further affect the motor control in the cortical motor areas, so that the RAS could further modulate the upper limb movement speed in PD patients. So this study of our team served as one of the pioneering studies which demonstrate the effectiveness of RAS on the upper limb movement in PD patients. And then when tackling bradykinesia at the upper limb in the PD patients is the target, then clinical practitioners may consider manipulating RAS. Okay, and then for the future research, actually our team now is conducting studies to develop the training program involving RAS and examining the effects of training programs on the movement symptoms in PD patients. And our team is also collecting neural imaging data right now in the auditory cortex and also motor cortex, and try to examine the brain changes in these, you know, related areas in response to RAS. And we are also assessing the long-term functional outcomes at 6 months after our training program. So we assess their hand function of doing daily activities. So So this is the end of my session. Thank you very much for being attentive to what I share, because I know that it's quite long. And then now this is the end, and then the following is the Q&A session. So I pretty look forward to any questions and also any suggestions from the floor. I did not present this data because there are a lot of data. There are a lot of studies that have already validated the effectiveness of RAS for the gait performance in PD patients. Because at the very beginning, actually now, if we search RAS or we say neurological music therapy as a keyword, and you search Parkinson's disease, there are a lot of studies focusing on the upper limb. So, for example, in United States, in clinics, the clinical practitioners may play some sound and ask the participants to move. And this technique, I also came across to see for patients with stroke. I also see some videos showing that the clinical practitioners play some sound and ask the participants to echo the beat of the sound and then to step forward and then to train. And then the videos truly show the improvements of the gait performance. So, but because there have already a lot of studies focusing on the gait performance, so I did not present here. So I mainly focus on the upper limb because so far there are still scarce studies validating the effectiveness of RS for the upper limb movements. Mm, 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 mm. Okay, so first of all, why I decide like 120% or 110% or 100% of the baseline tempo as a suitably faster tempo, because I refer to the earlier literature focusing on the gait performance. So there was one very typical studies validating the effectiveness of RAS incorporated in training for the gait performance for PD patients. And then they have already justified that 120% were okay. It's not too fast. It's not too slow. So it was just suitably fast. So I just build my study designs based on that design, and then to further validate whether this tempo could also be applied to upper limbs for different populations. And then the second question is about how I choose classical music, because there are so many different music. Actually, I also discussed with my team, and then because I would like to reduce the confounding influences of music. If they have lyrics, it's another story. And then if this music is very familiar for the participants, it may be another story, because it may, uh, trigger their motivation, and then the movement performance may be different. So at the end, I also consider the copyright, because if I use the pop music, like by the Taylor Swift, I need to pay, and I cannot pay. So So I work with my team and then to search what kind of music we may use, and I also refer to the literature. And then we found that actually there are some studies, although there are not a lot, but there are some studies using classical music because according to copyright, I even called the IP. The IP unit in Taiwan, and then to check whether it's okay for me to use the classic music as a research purpose. And then they say that because the classic music was composed by like Mozart or and it's already like more than 15 years or more than 100 years ago, so now there is no copyright issue. So considering I don't want to have many confounding factors like lyrics, and then considering the copyright, and at the end I choose classical music. And because one of my team members was the music teacher before, so we worked together and then we choose Mozart's composition here and then to prepare this. But we did not know if we change different types of classical music, whether it will induce different effects. So far, we don't know because we haven't conducted this type of studies. But you, mm, 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 mm. Yes. Mm, uh, mm, mm,
very strong reading.
mm, 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 mm. I think maybe it's possible, but we need to design our experiments because when we use the video games with a strong beats, we could hear RS, but simultaneously we also have some visual input. And actually in my studies, actually I could show you this. I could show you this result regarding the immediate effects. So here, so this is the result of immediate effect. Yes, so this is the result of the immediate effects of RS on the upper limb movements in schizophrenia patients. If you look at the data, for example, between the baseline and also normal. So baseline means without receiving any RS. Normal means RS with normal tempo. You could see that actually their upper limb movements become poorer. But if I provide faster RS, then their upper limb movements become faster. So actually, we also explain this kind of findings here. We found that compared with lower limb, if we provide RAS as an auditory cue to improve their upper limb movements are more complicated compared with the lower limb performance because we also need to rely on our visual sensory inputs. And then we found that if the tasks are more complicated, for example, they involve more sensory integration. For example, your test is very difficult, need your they have a high demand on the visual input. And then at this time, you play RAS, then perhaps 105% is not fast enough. So here we found that 100% RAS may not be good enough to induce faster movement compared with no RS condition, but 120% are good enough because when we compare baseline and also fast, they truly induce the faster upper limb movements. So if we go back to that video games, I'm considering, I think it depends how we design our experiments. For example, if they play that video game without any RS, and then they just look at that visual cue, and then they do the hand movements. And then for the second condition, we just let them hear the sound without any visual inputs. And for the third condition, if we combine together, and perhaps we could compare whether there are any differences in this kind of design. Because I think the difficulty of the task matter because it will affect the effectiveness of RS. Thank you very much for this very interesting question. I think 太鼓达人 is also very interesting. If we could combine Mm-mm. Right. Mm. Okay. Mm. Mm. The position of the effects. Oh. Oh. Mm-mm. Mm-mm. For the immediate effect, it's not a training, so I just would like to see whether I could immediately induce faster upper limb movements. So I did not examine the long-term effects. But for the functional training programs involving RS, currently I just validate the how to say that. I just compare the pre-test scores and also post-test scores. I did not have another timing to assess, for example, their movement performance at 3 months, after 3 months, or their movement performance at 6 months. I haven't done so, although I want, but I haven't done so. So I think this is also what I will try to do in my next step. Try to validate the long term effects of this kind of training involving RAS. Mm. 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 Right. Yeah. Yeah, because as I introduced, my training background is occupational therapy, and one of my expertise is motion analysis and also movement training. But I am not the expert in the area of neuroimaging. So actually, in my team, I work with other researchers in this area. But if I could collaborate with the expertise in this area, then I think we could work together and then to have more interesting finding in different populations. Mm, 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 mm. Mm, 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 mm,
Right. Yeah, because motion control, because, yeah, may fit my better. Yeah, before you enter one motion control, always apply for the certification when you work. So, uh,
I don't know. I'm not sure.
and
Mm, mm,
so I think
mm,
I think temporary.
mm. And then in order to echo, Professor Go's comments, I also would like to share all of my junior classmates here. Although today I present this sequence of different studies, but I would like to let you know that if you consider your research achievements, if you would like to generate your publications, and then that could be published in the high impact factor journals, you need to have a lot of efforts. As you could see, actually my sample size was not large because it's very difficult to detect POE from the community. Not to mention that I also need to do the 21-day training. So it's very difficult. But every time when I try to submit our research findings to journals, one of their concern is that you need to have larger sample size, even though your studies are significant, even though your assessment tools are very sensitive and also very objective. But they always care whether your sample size is large enough. So if you would like to, for example, if you would like to refer to my steps today, perhaps you could conduct this kind of small size randomized control trial and then submit it to the journal, perhaps with in the middle level. And then gradually, when you establish more evidence, and then you have already established a bigger pool of your participants, and then you could conduct a larger scale sample size, and then you could submit your research result to journal with a very high impact factor. Because, to be honest, compared with conducting other research, for example, correlational studies, you need a lot of manpower and also money to do the RCT, the randomized control trial. But even though you have already complete your small scale RCT after a lot of efforts and also money, it doesn't mean that you could submit your result to a journal with very high impact factor. But at the same time, if you use the same energy and also money, and then you find another interesting topic, very meaningful topic, which only involves like correlational studies or regression, and then you could build very large sample size. And actually, these kind of findings may be able to be submitted to a journal with a very high impact factor. But I just here share my personal experiences with you. Although, in our allied health fields, actually, we also feel very interested to know whether we could have some new intervention, whether we could, build some new evidence for the new treatment and to allow our field to get improvement. But, I believe that all of us would like to walk in the academic career in the future. So this is for your reference.